Hello, my wonderful computer science students. Welcome to another lesson of AP CSA, where I, Goldie, am going to take you through Unit 4 iteration and finish Unit 4 with our final lesson, Lesson 5, on nested loops. So we'll go over exactly what nested loops are and then see some specific examples of how we can trace through them and understand them. So a nested loop is an inception of loops, a loop inside of a loop. And here's kind of a visual for you on what that looks like. You have some big outer loop, and then inside that you have an inner loop, and you have what's called inner statements and outer statements. Inner statements pertain to the inner loop, and then the outer statements pertain to the outer loop. So the outer loop, the way we trace through these, the outer loop is checked. If it's true, we enter the outer loop. As soon as we enter the outer loop, we encounter the inner loop. And the inner loop is checked. If it's true, we enter that. The inner statements are repeated until the inner loop is false. Okay, so we get stuck in the inner loop, repeating that until the inner loop becomes false. And then we reach the outer statements, which will run once the inner loop is exited. And it'll run once. Outer statements will run, and then we repeat. We go back up, we check the outer loop. If it's true, we enter the inner loop. Inner statements are repeated, outer statements are then repeated once, and then check back up. Okay, loop inside a loop. A helpful trick that we're going to use kind of throughout these notes, and you can kind of use throughout the course too. Sometimes you just have to check how many times a loop will repeat. You don't have to do a full trace. Okay. Full traces for nested loops do get a little crazy because you have several indices to keep track of, in addition to usually extra variables to keep track of as well. So sometimes just understanding the logic behind a nested loop is going to go a long way in figuring out these loop problems. What do I mean? Okay, so we're going to go through 4 examples that just ask what is printed. What do the following nested loops print? So you can see here, these are 2 nested for loops. Okay. I have my outer loop here, my inner statements, and my outer statements. Okay. So my outer loop starts at I equals 1, I less than or equal to 3, I increases by 1. So basically the outer loop is going to repeat for values of 1, 2, and 3, meaning the outer loop is going to repeat 3 times. Okay, 3 times. Now my inner loop has a different indexing agent. It has a K. Okay, you can't repeat the I in the inner loop. Okay, I is 1. I has a value throughout the entire span of that loop. You need a new inner loop here. Okay, so the inner loop will repeat for values of 1 and 2 because K starts at 1 less than or equal to 2, and then increases by 1. So K is going to just repeat 2 times. The inner loop itself repeats 2 times. And what does the inner line inner statements do? They just print out an asterisk. Okay. So what gets printed? Well, the first time outer loop is true, inner loop is true, and we said this statement repeats twice. So I get 2 asterisks printed right next to each other. Then the loop ends and I print a new line. Okay, remember that this code means that I'm just printing on a new line. Then I just print that once. I go back up and I run through the whole thing again. Okay, so that means new line, and then I print 2 more stars. Okay, so my outer loop has now run twice. It's going to run 1 more, okay, where I get my 2 stars printed, and then my new line printed, but that doesn't show, and then my outer loop is done. Okay, so that gets printed to the screen. Okay, you could have also traced it like a normal trace. I is 1, K is 1, then K becomes 2, K becomes 3, the inner loop exits, I becomes 2, K gets set back to 1, so on and so forth. Okay, you could have done a formal trace like that as we go through, and if that helps you, absolutely do it, but I want to try to get you guys used to kind of logicking through some of these nested loops a little bit more. Okay. So let's try it with the next one. In the next one, it says I equals 0, I less than 10, I equals I plus 3. Okay. So what are your values of I going to be? Okay. Well, your outer loop will repeat for values of 0, 3, 6, and 9. Okay. 4 times. So that outer loop is going to run 4 times. The inner loop starts at k equals 1, k less than or equal to 10, k equals k times 3. Okay. So what values of k are your inner loop going to repeat for? Your inner loop is going to repeat for values of 1, 3, and 9. Okay, 3 times. So we got 4 times and 3 times. Okay. Now it's the same situation where we're printing the asterisk. Okay, so the asterisk gets printed 3 times because it's inside the inner loop. So your asterisk would get printed 3 times. Then you get a new line, and then it'll get printed again 3 times. New line, 3 times. New line, 3 times. And then it would get a new line at the end, but then your loop exits. Okay, so these the 3 stars represent your inner loop. Every time your inner loop runs, 3 stars gets printed. Every time your outer statements run, a new line gets printed. So that's why you have 3 stars and you have 4 new lines. Okay. Logic through it. You can do it. Those ones are not too bad to logic through once you get used to them. Okay. The tricky ones are going to come up next. What do the following nested loops print? Okay, why are these tricky? Maybe you can see why they're tricky. The outer loop is j. J equals 4, j greater than 0, j minus minus. So j, the outer loop will repeat for values of 4, 3, 2, and 1. So it'll repeat 4 times. The inner loop, however, will repeat depending on the value of the outer loop, because look at this. K equals j. Okay. For that declaration, k will always start off at whatever value of j you have. Okay. And then it'll print off k, okay, what that number is. So this one, let's start off, k is 4, okay, because we'll start off j is 4, so then k is 4. So k is 4, we print off a 4. K increases to 5. 5 is not less than 5. That loop ends. So I just printed off a 4. My outer loop, so my inner loop is done. My outer statements of my loop run. So I print that line once. And I go back up and I decrease j. So j becomes 3. 3 is greater than 0. I come in here, k is equal to 3. 3 is less than 5. So I'm going to print off a 3. I'm going to increase k to 4. 4 is less than 5. So I print off a 4. K increases to 5. My inner loop ends. Okay. I print off a new line. K is 2. And you can usually start seeing a pattern at this point when you're kind of tracing through like this. So k is 2, then k becomes 3, then k becomes 4. New line. K becomes 1 because j is 1. So I print off a 1, 2, 3, 4. And then I end. Okay? Because then j becomes 0. 0 is not greater than 0. So the whole thing is done because now 0 is not greater than 0. Okay. So the end result, this is what gets printed to the screen. So fun. Nested loops do have a purpose. Okay, right now we're kind of having fun with them, we're tracing them, we're seeing what cool things we can print off. They do have a purpose. Their purpose really comes into play with 2-dimensional arrays when we get to that unit. and we'll use these nested loops a little bit more. Okay. Right now, I want you to be able to trace them and to practice them enough to where you feel comfortable getting a solution here. Okay. Think of it like a big puzzle. Okay. So a big puzzle, let's see what picture this puzzle puts out. Okay. Okay, so last one of these examples, and then we'll move on to some multiple choice examples. The outer loop will repeat for values of 8, 5, and 2, because j starts at 8, decrease by 3, I get 5, decrease by 3, I get 2. If I decrease by 3 again, I get -1, and that's when my loop would stop. So the outer loop is going to repeat 3 times. My inner loop depends on the value of j again, okay, because I have that for k equals j. So the inner loop, when k is 8, when j is 8, k is 8. And when k is 8, that inner loop repeats 8 times. Okay. When k is 5, the inner loop repeats 5 times. And then for value, when k is 2, the inner loop repeats 2 times. Now, what gets printed off? What gets printed off in this situation is actually the value of j. And when we're in the inner loop here, we're not changing the value of j. In the inner loop, we're changing the value of k. J stays the same while the inner loop is running. Okay? Which means that this first line, when k is 8, k changes from 8, 7, 6, 5, 4, 3, 2, 1, but j stays 8 the whole time. We're inside that inner loop. So 8 actually gets printed off 8 times. Then we do a new line. J becomes 5, k becomes 5. So k is changing inside that inner loop, but j remains 5 throughout that whole loop. So we print 5 times. And lastly, we move to the new line. J becomes 2, so k becomes 2. J stays 2 while k changes and loops through and prints 2 twice. Okay. Those ones get a little tricky. Okay. We'll practice those a lot. We'll get used to those. But tracing these can be helpful. It can just be very long. Okay. So I want you to be ready for that. And when we reach the multiple choice part on the AP exam, we don't want to take a long time for these. So we want to get good enough to where we can start kind of using logic and patterns to figure out what the loops print. Okay. Okay. I have 3 multiple choice examples to finish off the lesson here. Okay. This first one, what output will be produced by this code segment? Okay. I see my nested loop. I love it. Okay. I see that my outer loop has I equals 5. I see that my inner loop depends on the value of my outer loop. And I see that I'm doing some fun math in here. With the value of j, which changes every time my inner loop runs. What the heck? Okay. Step by step, let's take it through. Outer loop will repeat for values of 5, 4, 3, 2, 1. 5 times. Okay. 5 times, which means I get 5 new lines. Okay. Now I look at my choices and I see each choice has 5 lines. Okay. So I can't really eliminate any options based on that. Okay. 5 new lines. Let's go to the inner loop. Okay. Inner loop. When j is 5, when I is 5, j is 5. And I'm going to repeat 5 times. When j is 4, when I is 4, j is 4. And I repeat 4 times. Then 3, then 2, then 1. Okay. How is this helpful? Well, for a multiple choice problem, this can help me eliminate some answers. Okay, especially if I'm pressed for time, right? I know I have 5 things that are going to get printed off on the first line, then 4, then 3, then 2, then 1. So I know it's kind of going to look like this little pyramid thing, or like triangle, right triangle. So I can eliminate C. I can eliminate D. Okay. Those patterns do not match what I should get. Okay. Without even having to evaluate anything, just knowing how my outer and inner loops work, C and D can be eliminated. Okay. Now I'm going to have to trace some stuff. Okay. So when j is 5, 2 times 5 is 10, minus 1 is 9. Oh, perfect. I eliminated D and C already. Now I can eliminate E because the first thing printed is going to be a 9. Okay, first thing printed is a 9. And I can see between A and B, the first line ends up being the same. Okay, so when J is 4, 2 times 4 is 8, 8 minus 1 is 7. Then I get 5, 3, and 1. Okay, because I already kind of figured that. My only choices left are A and B. Okay, then I move to a new line, and J starts at 4 on this new line. Okay, J starts at 4 on that new line. 4 times 2 is 8. 8 minus 1 is 7. So 7 gets printed off. All of a sudden, because I eliminated these as my possible answers, B is now my choice. Okay, B is the only one that matches the pattern I've had. So at first, what seemed intimidating to go through this, I already have an answer after only tracing through a couple times. And that's how the multiple choice questions are going to look. Okay. Eliminate options right off the bat as much as you can. Trace through as far as you need to go before you're able to see the answer. Okay. And you don't have to bother tracing through anymore, although you could if you really wanted to, but that would be it. B is your answer. Okay, second one. What will be printed by this code? Now I have a nested while loop. Okay, so notice here I have a while loop here, and inside here I have another while loop. Okay. A trace works best for while loops because you don't know how many times a while loop is going to run. A for loop you do, which is why we kind of use logic for those ones because we knew how many times it'll run and for what values it would run. While loops are different. It really needs a trace when it's kind of a mystery output like this. So the first line, x and y are 0. It says while x is less than 2. So 0 is less than 2. It says y equals 2. And then I have my inner loop here. Okay. While x times 2 is, or excuse me, x times y is less than or equal to 2. 0 times 2 is 0, which is less than or equal to 2. So I'll print off x and y, 0 and 2, and then y will increase by 1. Okay, so y becomes 3. And then please be careful, you're stuck in this loop. You have to go back up and check the inner loop. Okay? You do not move on to these until you're out of that inner loop. 3 times 0 is still 0. Okay? Print off 0 and 3, y increases to 4. You're still in this loop. You have not left. You have to go back up and check again. But what do you notice, right? You're stuck in that inner loop. X will never change. Y is the only value that's changing. And when x doesn't change, it's still 0. Anything times y, no matter how big it got, is going to be 0. That statement's always going to be true. You're stuck in that while loop. This is an infinite loop situation. Okay. Please, please, please be careful, okay, that you don't exit that inner loop before it is false. Okay. If it's always true, it's an infinite loop. Last question here. Actually, not a multiple choice question, although it could be, I suppose. But I just want you to write a nested loop that'll print off a 10 by 10 multiplication table. No problem, right? Okay. Let me show you. This is what I want you to print off, right? Not the table itself, but the values. Okay. Just print off the values. So how can we use a nested loop to accomplish this? Okay. Notice the patterns. Okay. Nested loops are very good when there's 2 patterns happening. Okay, and there's 2 patterns happening here. The first one, if you have an outer loop, let's just say that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I was committed, so I. And let's say you have an inner loop. 1, 2, 3, 4, 5, 6. There's a relationship between these 2 numbers, right? If my I is 5 and my k is 6, if I multiply those 2 indexes, I get 30. Okay, right? The indexes of my loop can be used to make my multiplication table here. Okay. So I'm going to have my outer loop start at 1 and go up to 10, and my inner loop start at 1 and go up to 10. So what I can have is my outer loop starts at 1, and I take my outer loop times every number 1 through 10. And then I'll move to the next line. My outer loop will move to 2, and then I'll have 2 times 1, 2 times 2, 2 times 3, 2 times 4, all the way up to 2 times 10. And then my outer loop becomes 3, 3 times 1, 3 times 2, etc., etc. Okay. Recognize the pattern. Okay. You have two numbers that are changing in a predictable way, and their relationship is that of multiplication. So your nested loop will look like this. Your outer loop goes by the row. Your inner loop represents the column. And you have your multiplication table. Good. All right. That brings us to the end of this lesson, and actually the end of the unit. So nice job making it through Unit 4. Thank you so much for following along with me, and I will see you in the next unit.